Hello and welcome to our virtual Lunch and Learn. Today we are talking about IntelliCenter Motor Control Centers 101. My name is Rachel Green. I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. And presenting for us today is Colin Fluke, Product Manager Power Engineering out of our Norcross, Georgia location. Out in the comment section, ready to answer your questions, is Kelly Etris, Power and Motion Solutions Consultant out of our LaGrange, Georgia location. We'll also have a Q&A portion at the end for Colin to answer your questions in more depth. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us. As you come in, let us know where you're tuning in from in the comment section. You can view previous recordings of virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist. And we cover a new topic every Wednesday at noon, so be sure to join us on your lunch break. For anyone just joining, welcome to our virtual Lunch and Learn IntelliCenter Motor Control Centers 101. Let us know where you're joining us from in the comment section. Hi, Manalang. Hi, Tom. Thanks for joining. For anyone just coming in, today we're talking about IntelliCenter Motor Control Centers 101. Colin Fluke will cover the basics of construction, components, Ethernet layout, and configurations in an intelligent motor control center. Our specialist, Kelly Etris, is ready to respond to your questions in the comments as we go along. We'll also have a Q&A segment at the end of Colin's presentation. If you'd like to reach out afterward or if you have further questions for Colin, you can always send us an email at macandmaclive@macandmac.com. Be sure to let us know which session you attended and we'll direct your question to Colin. We'll have that email address on the screen for you at the end as well. And it looks like we have a number of viewers with us now, Colin, so I'm going to pass it over to you.
Thank you, Rachel. So starting out with IntelliCenter Motor Control Centers, we'll start with some of the basics here. So an MCC, short for Motor Control Center, is a device that has everything you need to be running in your plant, from across-the-line starters, soft starters, VFDs, feeder breakers, everything all included into one unit. So let's start with the basic construction. 90 inches tall, 15 inches deep are the standard sizes. Also common is a 20-inch deep MCC. A lot of them are front-facing MCCs, which means they are mounted against a wall facing forward. But there are also back-to-back MCCs, which you're combining two MCCs right back-to-back. We have different enclosure ratings in Allen Bradley 2100 MCCs from a NEMA 1, a 1G, which includes gasketing, a NEMA 12, a 3R non-walk-in, people like it for outdoor uses, as well as a stainless steel model. So the Centerline 2100, why is it called Centerline? It's because the power bus for the MCC is located in the middle of the MCC. So this power bus rating has a bus for each phase, A phase, B phase, and C phase. The ratings vary from 600 amps all the way up to 3000 amps, with current withstand ratings from 42K, 65K, or 100K. This horizontal power bus is what carries the power throughout the entire MCC, all the sections. Now in each section, there's a vertical power bus. This vertical power bus takes power from the horizontal bus and distributes it vertically, up and down from the centerline bus. These ratings come in an effective 300 or 600 amp rating. We'll explore that a little further on the next slide. We also have an optional neutral bus. This can be half rated or fully rated in the MCC. Now talking about the vertical power bus, we have a 300 amp and a 600 amp bus. Now since the horizontal power bus is located in the middle of the MCC, it's an effective 300 amps above and 300 amps below, giving you 600 amp capacity in that section. So if you have a 600 amp vertical power bus, you have 600 amps above and 600 amps below for a capacity of 1200 amps. Now, each of these little white vertical sections we can see is where the power stabs for each bucket plugs into the MCC. So in Allen Bradley MCCs, we have plugs to cover those power stabs so you're not exposed to the bus. We have manual shutters, which you still have to stick your hand in and adjust the shutter for any bucket you plug in, or automatic shutters are available. These are very popular, and it's all a mechanical mechanism. When you plug the bucket into the MCC, it hits a switch that physically opens a shutter behind the power stabs and allows you to plug the bucket in fully so you can not have to be exposed to the vertical power bus. Now, construction, very, very durable. So as we can see in item 1, we have dual side sheets on the sections. These are steel side sheets that minimize arc propagation in the event of an arc flash. Located at item 2 is a solid lifting angle. These are detachable. These can be unbolted, but this lifting angle allows easy movement and positioning of an MCC section. In item 3, we can see that's the location of the horizontal power bus in the middle. Item 4 at the bottom is the ground bus. So we can have a ground bus in the bottom or the top or the bottom and the top. In item 5, this is an internal mounting angle. These are supports that you can use to bolt the MCC section down in the field. So when we're talking about motor control centers, a term that always comes up is space factor. So a space factor is the unit allowance and size of each bucket. A bucket is a unit, such as a VFD or a starter or a feeder breaker. So in these space factors, these buckets are identified as sizes of space factors. A space factor is 13 inches high in a Allen Bradley Motor Control Center. So we have a 6 space factor capacity. So in the very top of this section on the right is a single space factor unit. Right below it is a half space factor unit. Further below it, we see again a 1 space factor unit that is a starter. And below that is a 2.5 space factor VFD. This gives you an idea of the sizes, physical sizes of the units in the MCC sections. So looking at a unit, so on the left here, this is a picture of a FDNR starter. We can see all the components from the contactor in the top left to the overload relay below it, as well as on the bottom, the 3 sets of plug-in terminal blocks. We can see the circuit breaker in the top right. Now this circuit breaker is mechanically connected to the breaker handle on the outside of the MCC. So it is full mechanical operation when you're turning on a bucket or turning off a bucket. On the picture on the right, these are the power stabs on the back of the bucket, one for each phase. These are spring-loaded clips that clip into the power bus, the vertical power bus, and allows power to come into the line side of the unit. Now in the top right, we see a small little square of that, a little copper. That is a copper ground stab. So that copper ground stab actually protrudes farther than the clips, so that when you are plugging in a bucket to an MCC, that ground stab engages the ground bus and connects to it before power bus is even connected. So that way you are grounded before you even come into contact with the vertical power bus. So unit features. So on the circuit breaker handles, the disconnect handles on the outside of the MCC, we have a capacity for up to 3 padlocks for lockout tag out procedures, as well as an additional lockout position in, as we can see in the picture on the right. This is when the bucket is disconnected and pulled out of the MCC. So say you have a maintenance guy in the field who's doing work on a motor, and he has pulled the bucket out of the MCC. He may do a lockout tag out on that position, on that tab right there, and it prevents anybody from plugging in that bucket to the MCC. Even if the disconnect handle is off, there is still not a chance that any power can come into the line side of the bucket. So just another good lockout tag out position. Now, space is always a concern when we're talking motor control centers. A lot of people have motor control centers installed in the field, but do not have room to expand the motor control center if they add another line or an additional motor anywhere. So if there are empty spaces in an MCC, we can use what's called space-saving unit designs. So like in this unit in the top left, this is a size 4 FENR starter. Could be 100 horsepower. But this is space saving, which allows us to plug it into just one space factor instead of, say, a 2.5 or a 3 space factor unit. Feeder breakers in the middle on the bottom. So this is a disconnect that is a half space factor. So say you only have one space factor unit, but you need two 50 amp breakers. Well, using this design will allow you to include those two 50 amp breakers. One thing to note is we can see the disconnect handle is actually horizontal in these space-saving units. Now, what can you put in an MCC? You can put everything from NEMA starters to molded case circuit breakers, VFDs, soft starters, transformers, lighting panels, just about anything you would have running a motor in your plant or feeding power anywhere in a plant. Now, with Allen Bradley's Centerline 2100 MCCs, we have over 40 years of backwards compatibility. That means you could have an MCC from 1982 and an MCC from 2015, and you can still pull a bucket from that 1982 MCC and plug it into the 2015 MCC, and it will fit and it will work. So this is very, very good. You have less replacement units, less spare parts inventory. If there's going to be a plant upgrade in 10 years, you know that your Allen Bradley MCC will be capable of fitting the new units instead of having to buy, a whole new MCC structure. So with Centerline 2100 motor control centers, there's also a line of ArcShield motor control centers. So these are built like tanks. And they have higher steel construction. Everything is built to minimize arc propagation. So taking a look at this next slide, we can see some of the features. We can paint the door yellow for easy identification of the main breaker. We have reinforced enclosures, so the steel is thicker throughout the entire MCC. The hinges on the door are actually spring-loaded. So in the event of an arc blast, there's quite a release of gases, and those gases can actually push the door out, and those springs will allow the door to open slightly for the gases to release, and then we'll close the door upon the release of the gases. It's a very cool feature. As well as we have specific current limiting protection units, and the support pans are all reinforced. So very, very neat safety features in concerns of ArcShield and ArcFlash. Also safety features, this is with ArcShield or standard Centerline 2100 MCCs, is a feature called Secure Connect. So Secure Connect allows you to have a bucket plugged into an MCC and physically disconnect all power to that bucket, isolating it. So not even power coming in on the line side of the breaker. So it does this by a mechanical mechanism that is operated on the front of the unit door. And upon operating that mechanism, the 3 power stabs actually rotate vertically 90 degrees into that black box, and then a spring-loaded shutter will close, isolating that bucket completely from power, with the ground stab still connected. So this Secure Connect on the front also has an optional unit to plug in a continuity meter. So you can do this to confirm that power has been completely disconnected from all the power stabs. as well as the little white box underneath the circuit breaker handle there. That is the mechanical mechanism. This whole feature of Secure Connect can be operated with a T-handle wrench, a ratchet wrench, or even a remote motor. So there's a little motor module you can mount on the door, and you can stand 20 feet away and press a button, and it will activate the Secure Connect, turn it via the motor, and then completely isolate that unit with the operator standing at a clear distance. So talking about IntelliCenter Technology, most plants are all connected through the plant-wide enterprise. So MCCs have also built in IntelliCenter Technology. This is a built-in network that is installed, configured, and tested at the factory these MCCs are constructed at. So it allows intelligent motor controls for the power flex drives, SMC flexes, overload relays, starter auxiliaries, and any ENet or device net configurations that the plant may have. Also included is an IntelliCenter software. So this enhances whole system-wide communications to your MCC. And we'll take a closer look at that here shortly. So in each of these intelligent MCCs includes an Ethernet switch. This Ethernet switch is an Allen Bradley Stratix 5700 Ethernet switch. We can put 6 ports, 10 ports, 20 port switches, or even a 20 and a 10 port switch to make an effective 30 port switch. So these switches can be mounted in various locations of an MCC. Here we can see a bucket mounted option. These are buckets that can either be put in the top bucket or the bottom bucket of an MCC, and these are frame mounted, which means instead of pulling a bucket in and out, they are physically bolted into the MCC, the switch. So here on the picture on the right, we can actually see one of the Ethernet switches mounted on DIN rails in the unit, and the cables running out of the switch into the bottom horizontal wireway, and then vertically up through the vertical wireway to each component in the MCC. So these are bucket mounted switches. These are horizontal wireway switches. So if space is a concern in an MCC and you don't want to use the space, limited space that you have for an Ethernet switch, we can actually put the Ethernet switch in the wireways. This may be the top wireway or the bottom wireway. The picture on the right, we can see a visual of this. It is mounted on the very back of the wireway, so you still have clearance for bringing in cables to each component. And these Ethernet cables, again, are ran out through the wireway and then down each vertical wireway to each component. So when you have a bucket-mounted Ethernet switch, the max capacity of the Ethernet switch is determined by the amount of ports, as well as the amount of sections it covers. So here on the left, we have an Ethernet switch in the top. That is a 30-port Ethernet switch. But we have maxed out at 9 sections. 9 sections is the max amount of sections that a single Ethernet switch can be wired to. So here I added an additional Ethernet switch in the 10th section to cover those 2 VFDs and any further expansions to the right of the MCC. So the Ethernet wiring in the MCC, it is all home run and a star topology. This means that there's a single cable from that Ethernet switch going all the way through the MCC to the component that it's connected to. So here we can see on the right the Ethernet cable coming down the wireway and then going into the side of this starter, it looks like, and plugged into the E300 overload. It is a single cable from the Ethernet switch to the unit using in the star topology. Now, instead of having a single cable from the switch to the unit, we can also put optional wireway adapters in the vertical wireways. This is Ethernet ports in the wireway that are connected to the Ethernet switch. So this is very convenient if you're going to be moving buckets around in the field often, or easy troubleshooting for anything. It's shorter Ethernet cable lengths. It minimizes having to fish Ethernet cable through the entire MCC if a new bucket was added. So it allows just a short cable, maybe 2-3 feet long, straight out of the unit, right into the vertical wireway adapter. Now, also included in IntelliCenter MCCs are 24-volt wireway adapters. So each IntelliCenter MCC has the Ethernet switch, but it also has an Ethernet power supply. This power supply is a 24-volt power supply that goes to all components that require 24 volts in the MCC, whether it's overload relays or the switch, or maybe auxiliary power supplies on the VFD. So here we have the Ethernet wireway adapters with the 24 volts. But what it also allows you to do is if you wanted to hook up a meter to one of your units, say, and have it record data for about a week's time, instead of having an extension cord run across the plant going in through a door, you can pull 24 volts directly out of these wireway adapters straight into the unit. So very convenient if the need be for 24 volts is there. Now, the topology and switch configurations in an MCC vary. So standard, an Allen Bradley MCC will come with a linear start topology. That's that home run wiring we were looking at, a single cable from the switch all the way to the unit. But there's also device level ring and switch level ring topology. These need to be specified so that we can engineer the MCC to account for this. Now, when ordering an Ethernet MCC, the default IP addresses we assign is the standard 192.168.1.001.002 and so on. We can also assign the IP addresses to each component if those are supplied. Now, in the bottom, we can see a list of some of the features we can add on these Stratix 5700 Ethernet switches in the MCC. So if gigabit is needed, or smart port or DHCP is needed, it can be requested and we can add it. Also optional adders is a viewing window or an external Ethernet connector. Some IT or OT guys may prefer this for easy viewing of the Ethernet switch or plugging up their computer straight to it without having to open the door. So here we have an example of the software. So the software that comes with the IntelliCenter MCCs allows you to run diagnostics, see real-time data of the entire MCC, as well as send notifications for alarms, warnings, faults, if there's a trip in the unit, anything like that. So let's take a look at some screenshots of the software. On the left side here, we can see a real-time view of the MCC. We can see each component, every bucket in the MCC. We can see what's running, what's not running, where we may have a fault, and then we can diagnose further into each unit. So to the right of that image is an image of a PowerFlex 70 drive. So here we can go further into the drive, and we're able to either jog the drive, start, or maybe stop the drive directly from the software. Next to that image, we can actually see the real-time data trend of the overload in that unit. We can see the average amps that it's pulling in real time, as well as the percent of thermal utilization that's happening in that bucket. So this is very good because it also creates trends of what is happening over time. So you're able to see, say, if an overload tripped at 3 a.m. in the morning, and you get in at 7:30 or 8 a.m. in the morning, we're able to go back and see, why was that overload tripping? What was happening before that overload? Or why were more amps being drawn? So you can always see the progressive patterns of what's happening in the MCC. To the right of that, we can also see further real-time data and parameters. Here we can set warning statuses, trip classes, the full load amp ratings, and we can see any current imbalances, or we can directly see a meter of the current that's being drawn. So very cool features that the IntelliCenter software offers. Now it also has a database of all the parts, such as the spare parts, the manuals, and even the wiring diagrams of all the units in the MCC. So if you have a PowerFlex 70 drive here, and you need a new communication cable for your HIM module, we're able to quickly and easily see that the part number I need is a 1202-C03. And you're able to contact the local McNaughton-McKay office, and we can get you a quote for that. Also included is the wiring diagrams for every unit. So inside of an MCC, the physical paper wire diagrams are included in envelopes of the MCC. Now, you also get a digital copy with the IntelliCenter software. This allows you to easily access and see wiring diagrams of any unit directly from the software, as well as user manuals for every component. So say you have a frame H feeder circuit breaker and you need to digitally adjust the trip. Well, you're able to quickly access the user manual for that frame H circuit breaker and find the instructions for digitally changing that trip, all included in the software. Now, utilizing the software also has integration with RSLogix 5000. So a lot of people like this when they have PLCs throughout their plant. You can easily map parameters straight to the controller tags on the RSLogix 5000, as well as any simple device replacement. So if you have a, say a VFD in the field that goes, and you order a new VFD, you can easily pull that old VFD out, put the new one in, and run the configuration software, and it'll download all the parameters and all the settings from that last VFD to that new VFD for quick and easy replacement and integration. So very, very unique features of the software. And with that, I will conclude and send it back to Rachel. If there are any questions or comments you'd like to answer.
Thank you, Colin. We don't have any questions in the chat right now, but I'd like to give just a few minutes to see if anyone has any follow-up questions for you. So while we wait, I'll just remind everyone you can always reach out to us via the email address you see there on the screen at macandmaclive@macandmac.com. You can send us your questions even after this live stream has ended, and we'll pass them along to Colin. Just let us know the name of the presentation you attended. And with that, I'd like to thank you, Colin, for this wonderful presentation. Thank you, Kelly, for being our resource out in the comments section. And thank you for all of our live viewers today. We hope this session was informative and engaging for you. Remember to subscribe to the McNaughton-McKay YouTube channel for more industry content, and we look forward to seeing you live again soon. Thank you, everyone, and have a great day.